Welcome everyone to the next lesson in this series, Pod Networking for Kubernetes with Calico. Now, in one of the previous lessons, we looked at IP address management for Kubernetes. And IP addresses are assigned to what is known as a pod interface, which is created during pod startup by the container network interface plugin, by the CNI, Calico in this case. So in this lesson, we will look at the process that is involved in the creation of this pod network, as well as the underlying plumbing that facilitates network communication for pods in a Kubernetes cluster. So let's get started. So first of all, some of the basics out of the way. Why is pod networking required and why should the CNI provide this functionality? Well, pods in a cluster are dynamic, they are ephemeral, and as pods are started, the CNI should create the interface so that these pods can communicate not just with workloads inside the same cluster, but also workloads in your broader environment. Now, in a given cluster, you could have thousands of pods, so you need an automated process to create these interfaces as well as manage the IP addresses for these pods. Number two here is network isolation. These pod interfaces are created in a separate network namespace, and you can configure certain network security controls for these interfaces that could isolate network communication for certain workloads in the cluster. So it is also a security mechanism. Number three here is service discovery. Now, as part of the pod network creation process, Kubelet configures DNS for this pod, and DNS is what facilitates service discovery in a Kubernetes cluster. And the fourth point here is container to container communication. Now, in a given pod, you can have multiple containers, and these containers should be able to communicate via local host. And the dedicated network namespace for a pod is what ensures that only containers within a certain pod can communicate to other containers via local host. Okay. So these are some of the reasons as to why the CNI has to provide pod networking, and it often does so at scale in a Kubernetes cluster. All right, so next let's look at the process that is involved in the creation of these pod interfaces. So let me bring up another diagram here and let's go through this process step by step. Okay, so in a Kubernetes cluster, we have the Kube API, and in every node in the cluster, we have kubelet, right? Now, when Kube API receives a request for pod creation, a component that is not shown in the diagram is the scheduler. The scheduler determines which node this pod should go into, and then Kube API sends the pod creation request to kubelet in that particular node. Now, when kubelet sees the request for a new pod, it calls the container runtime in that node. Now, the container runtime does many functions, one of which is the creation of the pod network namespace for a given pod creation request. Okay. Now, once the namespace is created, the container runtime invokes the CNI with the CNI add command, and the CNI will call the IPAM plugin to obtain an IP address for that pod. Now, once the CNI receives the IP, it creates what is known as a virtual Ethernet pair. And this virtual Ethernet pair has two ends to it. The first end of it is the ETH0 interface, which is created in the pod network namespace. And the other end of it is what is known as a Kali interface in the case of Calico, which is created in the host network namespace. Now, this is known as a virtual Ethernet pair, which is a type of interface that you can create in the Linux operating system. So CNI creates this interface, and in addition to creating the interface, it also configures the routes in the pod as well as the routes in the host so that this pod can communicate with other workloads in your environment. And we will look at this in detail during the hands-on lab. Okay. Now, once the interface creation is complete, the CNI updates, or rather the binary that runs both the CNI and IPAM plugin, which is a single binary in the case of Calico, it updates the data store with what is known as the workload endpoint details. And the CNI gets back to the container runtime with the results of the veth creation process, and the container runtime gets back to kubelet, and then kubelet gets back to Kube API, right? All right, so looking at this, you might be going, well, that is a lot of information just for the creation of a single pod network. Now, there are certain nuances to this process as well. I've tried to keep it as brief as possible. And the objective is knowing this process hopefully helps you understand and effectively troubleshoot issues that could arise as pods are spun up in a Kubernetes cluster. Okay. Now, in the hands-on lab, we will look at some of the underlying plumbing that hopefully will give you a good foundational knowledge as to how networking works for pods in a cluster. So I'll see you in the lab. All right, so next let's go through the lab. Now we have a separate lesson and video that walks you through how to provision the lab environment. Hopefully you've looked at that. And if you've cloned the repo, in the repo we have a folder called container lab. And in the container lab folder, there's another folder called pod network, which has all the files needed for this particular lab. Now, if I do a tree-l1 here, this is the structure of this folder. And the files in this structure are very similar to the files that you saw in the IP address management folder. We have a container lab topology. So if I do a cat, and if you look at this topology, it's very simple. It has a kind cluster. And if we look at the manifest for the kind cluster, we are deploying a 3-node cluster with no CNI, since we will be installing Calico CNI, and with a pod subnet of 192.168.0.0/16. It is essentially the same lab as the one we had for the IP address management lesson. Now, there's another folder here called tools, and in the tools folder we have a manifest for a multi-tool pod that we will deploy in the kind cluster, and we will use this pod to analyze the network configuration of the pod. Okay. Alrighty, so I have already run the deploy script that you find in this folder. So this is the deploy script. I have already gone ahead and run that script. So the kind cluster and the container lab topology is up in my environment. If you want to look at a walkthrough of how to run the deploy script, we do so. And I have recorded that in the IP address management lab or lesson. So, feel free to have a look at that, and, feel free to follow along as well. So I've run the deploy script and the container lab topology is up and running in my environment here. So what I like to do first, once the topology comes up, is to, have a look at, or rather inspect the topology. So we see the 3-node kind cluster, 1 control plane node, 2 worker nodes, and these are the IP addresses of my node. The script also spits out a kube config file. So I have my kube config file over here. This is an output of the deploy script. So let me set that up as an environment variable. And we can then do a kubectl get nodes, dash or wide, and you can see that the node IPs, correspond to the IPs we saw in the container lab topologies. These are the node IPs of the kind cluster. So I have my cluster up and running now. Please note that the outputs that you're going to see in the subsequent sections could be different from your environment, right? And that's because everything in the lab is dynamic. Even the node IPs can be different in your environment. So just bear that in mind as you're going through the lab. The important thing is that you understand conceptually how things are configured under the hood, but your outputs could be different from my outputs over here. Okay, so if we look at the pods in the default namespace, we have the multi-tool pod. This pod was deployed in the kind cluster as part of that deploy script. Okay. And what we're going to do next is we're going to exec into the multi-tool pod. Now, before I do that, let me open a diagram, right? So this is what the underlying plumbing looks like. We have the pod network namespace, which was provisioned by the container runtime. We have the host network namespace, and we have the VF pair, the virtual Ethernet pair, that was provisioned by the CNI, Calico in this case. And we also see the routes in the pod and the hosts that were configured by the CNI, right? So a lot going on in this diagram, and we will dissect this step by step in the lab walkthrough, okay? So what I'm going to do first is I'm going to exec into the multi-tool pod. So the multi-tool pod is a pod in the default namespace, and we are going to exec into it. So we're basically inside this pod, okay? All right, so inside the pod, if I do a IP ADDR, it's going to give me the interfaces and the IPs of those interfaces configured in the pod. So we see two interfaces. The first one is the loopback interface, which is used for local communication within the pod. And the second interface here is the ETH0 interface. It has received an IP address of 192.168.146.66 from the CNI, and the CNI receives that from the IPAN plugin. Now, as you look at this output, you're going to see something called link net network namespace ID 0. And this is the ID of the opposite end of the virtual Ethernet pair. So essentially, this is the IP of the host network namespace. So if you look at this diagram, this is the pod network namespace, and this is the host network namespace. So in this output here, you have the network namespace of the opposite end of the V8 pair, which is the host network namespace. All right. And the IP address is of the ETH0 interface that is attached to the pod is 192.168.146.66. So this is the IP address, right? And if you look at the name of the interface, it is ETH0 with a suffix of IF6, interface 6. And we will look at this when we go into the host and analyze the host side configuration as well. What IF6 essentially means is in the host side virtual Ethernet pair, which is the Kali interface, is interface number 6. This is what it essentially means, right? So IF6 here is interface 6 on the host side, which is the opposite end of the virtual Ethernet pair. Okay. All right. So that's the IP ADDR output. If you do an IP link, again, you will receive a similar output. We see the opposite end, opposite network namespace ID of the V8 pair. You can also see that this particular interface has received a MAC address as well. Again, the CNI will allocate a MAC address for every pod interface it creates. Okay. And if you do an IP route, you're going to see the default route that the CNI configures for this particular pod. So we have the default route over here, and this default route points to the ETH0 interface. So what this essentially means is if this pod wants to communicate with any other workload, be it inside the cluster or outside the cluster, this is its default gateway. It's gonna punt that traffic out the Ethernet 0 interface. Now you're going to see an IP address here, 169.254.1.1. This is known as the link local IP address. It's like a phantom IP, right? Calico uses this IP to configure the default gateway. And in the pod routing lesson, which is the next lesson, we will look at in detail the steps that are involved in routing packets in and out of a pod, right? But for now, it's adequate that you know that the default route is configured and the default route points to the ETH0 interface. And if I do a cat etc resolve.conf, I can see the DNS configuration. So the name server is configured as 1096.0.10, which is the service IP of kubedns in the cluster. Okay. Now there are some other search domain configurations as well. There's an n.dot configuration. I've given the description of those in the MD file here in the repo, but we will look at these in detail when we look at the DNS chapter or the DNS lesson in this series, right? For now, it's adequate that you bear in mind that Kubelet, as part of the pod network configuration, configures the name server, which is the DNS server that this pod will rely on when it tries to resolve host names or service names that it intends to communicate with. Okay, and that DNS server or name server corresponds with kubedns, which is a service that the Kubernetes cluster provides for all of its workloads. Okay. All right. So in the pod, we looked at the interface and we also looked at the default routes. So what I'm going to do next is exit out of the pod. Now, bear in mind that this is a 3-node kind cluster. So I exited out of the pod. And now what I'm going to do is I want to find out which node this pod is scheduled in. So this pod, which was the multi-tool pod, is scheduled in worker node 1, right? And what I'm going to do next is I'm going to exec into the worker node. I'm going to exec into the host, right? And this is container lab. So the host or node is essentially a container, right? So I'm going to use a docker exec to get into that node. So now I am inside the node. So I'm basically over here, right? So inside the node, if I do an IP route for the pod's IP address, I can see that that route is pointing towards the opposite end of the VEth pair, right? So this is the VEth pair. I'm in the host, and if I do an IP route, it's pointing towards one end, basically, of the VEth pair, which is an interface that is suffixed with Kali. That's how you know that this is an interface that belongs to a pod, right? And as I look at this interface, so let me go back to the lab, and if I do a IP-ADDR grep for that particular interface, right, to look into the details of that interface. So as I look at it, I'm basically over here, and you can see that this is the 6th interface in this host. So if I do a IP-ADDR, this host has several interfaces, I think a total of 8, and this particular interface is the 6th interface. And that's why when we looked at the ETH0 interface, we saw it suffixed basically with IF6. So Kali, I think I mentioned that it was suffixed. So Kali is basically a prefix that is applied to interfaces that belong to pods, right? And that is a Calico specific annotation there. So basically this interface is the 6th, and that's why we saw this suffix configured in the ETH0 interface. And if you look at the name of this interface, it has a suffix of IF2 interface 2, and that corresponds with the fact that the ETH0 interface was the 2nd interface in the pod. Okay, so that's basically just to help you understand some of the semantics involved in the naming of these interfaces. Okay. All right, so we looked at the route, and let me just clear my screen. Let's get those outputs again. All right, so we looked at the route. This is the route over here. It points to the Kali interface, and we also looked at the configuration of that particular interface. Now, in the configuration of the interface, you're also going to see linked network namespace with a namespace ID. And as you rightfully might have guessed, this is the namespace ID of the pod network namespace. Okay. All right, so there you have it. This is how the networking is plumbed for a pod in a Kubernetes cluster with Calico CNI, right? So we looked at, to summarize, the pod network namespace, the configuration of the routes, how those routes point to the virtual Ethernet pair. And we looked at the host network namespace, the routing on the host network side, and how that points to the other end of the VEth pair, and some of the semantics involved in the naming of these interfaces as well. All right. So with this understanding, in the next lesson, let's look at pod routing. How are packets routed so that a given pod can communicate with not just other pods in the cluster, but also with other services that are external to the cluster, or even receive traffic from external sources, to the cluster. So that is the next lesson. I'll see you there. I hope you enjoyed this one. Thanks for watching, and bye for now.